Hello everyone. Today we'll be seeing how to control placement through chip planner and how this placement is gonna affect the timing of the circuit. Finally, we'll be seeing how to run our FPGA board without deploying the code from Quartus Prime. How to run your FPGA independently. So before that, we'll be compiling our code with the default pin planner assignment, and which I've already done that, and here are my results. So I have got a very less delay with the default pin assignment. As you can see, I've got an average of 5.7 nanoseconds with that. And now if you see the chip planner, this is not the default chip planner which was generated, and as you can see, this was the default report path which was generated earlier. Now you can change this placement this way. Let me just show you with an example. Let me just enlarge this. Yeah. As you can see, these report paths are depicted by the lines over here. Now, if I want to change this placement, I just have to drag it down, select this, and now if I draw a line to a different register, and if I assign this over here, yes, now you can see I have changed the location of this register from this particular block to here, and the assignments are shown at the bottom. As you can see, this is my latest assignment. I have assigned this particular node from this location to this. So with such changes in your placement can actually reflect in the delay that's gonna come in your report path. Now I have changed this. I can save the circuit, and if I recompile my code, I will be getting this new assignment in my pin planner. So with that change, which I've already done that, I have assigned my previous register from one location to x1 y1, and another register from another location to x20 y80, and I have saved it, recompiled my code, which actually increased my delay from 5 nanoseconds to 30 nanoseconds. I have the results for you. Yeah, as you can see, these are my results after changing the placement from one location to another. So you can see here, this is my latest delay, which has increased significantly from 5 nanoseconds to 30 nanoseconds. Yeah. So if I'm gonna change to a different design altogether, I can do that. I can change n number of designs. All these design changes help us to emit the required delay. Let's say I want 5 nanoseconds right now for a particular task. I want it to be 30 nanoseconds later. I can do that with my trial and error methods of changing the placement from one location to another. So now let us see how to run our FPGA board autonomously without the help of Quartus Prime. For that, you would need a bat file, which I've already in place. So this is my SOF file, which was generated after compiling. And now in this batch file, I have already placed my required credentials. I've already placed my required file paths. So I'm gonna directly run this. Yeah, I think it was a successful run. Yes, as you can see on my FPGA board, you can see a static display of zeros. I didn't use any Quartus Prime. I just directly run the batch file and that's it. So with this help, what you can do is that you can have this batch file configured to your required needs, so that you can pass in an SOF file as a parameter. You can run different SOF files on the same batch file. You can have that autonomously run. Let me show you an example from the last week. Let's say I have my multiplier SOF file from last week. I just have to change my batch file. Let me just do that for you. Okay, let me just copy this. Control C. Okay, now let me just edit this file. Edit with Notepad. As you can see, if I come a little bit down, now if I change this file to my previous week's multiplier and save this, and now if I run my batch file again, you can see that my multiplier has been deployed. Let us fastly see 4 cross 3. 4 cross 3. C12. Let's see 6 cross 8. 6 cross 8, which is 48. I can deploy whatever I need. When I can deploy my LED display, I can deploy my multiplier, I can deploy whichever thing I want on my batch file, and that's going to run my FPGA autonomously. That's all it for today, guys. Thank you.